gonna look something like this. And we have symmetry, so it's gonna be like a circle that it basically gets like one pole, it's gonna move like this and then goes here, the other one like this and goes here, or the other way around. And the closed loop system is always stable because both of the poles are gonna be on the left hand plane. Okay, so that was about root Lucas. I hope you guys got the hang of it. It's a little bit challenging because this is the first time you see this, so make sure you do enough practice. At least do like all these 5 examples we did and the examples that Dr. Jeff put in the notes one time yourself to get familiar with this concept. Now, the next topic we're gonna like briefly review different commonly used controllers. So this is reference, this is going to be error, this is going to be our controller, this is our plant, and it just should be capital. Okay, so one main category or family of controllers are combination of proportional integral derivative controllers. So after finding out the error, basically either like we like multiply that error by a factor and give it to the plant to adjust the so give it to the controller to adjust the input to the plant, or we take the integral of the error and give it to the controller and find the new modified input to the plant, or take the derivative of the error, okay, or a combination of all of them, or a combination of 2 of them. Okay, so that's the PID controller, P controller, PD controller, ID controller. Those are different controllers that we can have. So let's look at one example. This is not electrical example, it's actually a mechanical example, similar to what we saw before. So this time we just like have an object, we apply a constant force, not a constant, like we apply a force, right? But this is it's just like, let's assume that if it's a unit function, it means like it's going to be constant. If it's sine, it's going to be oscillating. But it's not just like a pulse. It's like either like a unit, or it can be sine, or it can be many different things. There's friction here. So let's find the dynamic of the system. So F of friction is always equal to the friction coefficient, negative friction coefficient, times the speed, x dot. And we also know that sigma F is equal to ma, right? So this is the force that we are applying. U minus bx dot is equal to mx double dot, right? If I take Laplace transform u of s, let's just like take that one to the other side, this term to the other side. So this is going to be ms2x of s plus bs x of s. And if I factor out x of s, it's going to be ms squared plus bs. right? So the plant transfer function, which is gonna basically give us the ratio of x divided by u. It's gonna be um, 1 over ms squared plus bs. Okay, so this is the transfer function of the plant, or like we can also, like in the standard format, I can write it as S2 plus B over ms 1 over m. Doesn't matter which one you use. Okay, and let's assume that we have a proportional controller. Means that this one is just like a constant. Okay, so if that's the case, then our closed loop system, it's gonna become gc times gp, so it would be k over m divided by let me actually do it like this, k over m divided by s2 plus, actually it's easier to use this one, k over ms squared plus bs divided by 1 plus the same thing, k over ms squared plus bs. If I simplify this, it's going to be k divided by ms squared plus bs plus k. So if I use a proportional controller, now my closed loop transfer function changes from this one to this one. Okay, so now by changing k, you can basically control the value of y. This is going to give us the ratio between y of s and y ref of s, which is this one. This is like, let's say, y ref of s or r of s, doesn't matter. Okay. So by choosing, this is a second order system. By choosing the value of k, you can actually find the frequency, natural frequency, the damping. You can choose like many different, like many of the performance characteristics of the system can be changed by changing the value of k. Okay, so this is an example of a proportional controller and how it changes the closed loop transfer function.